Hello everyone. In this video we're going to be doing range sum of BST, which is binary search tree, which is LeetCode problem 938. So this is an easy problem, and it states, given the root node of a binary search tree and two integers low and high, return the sum of values of all nodes with a value in the inclusive range. So what that means is, in example 1 here, you have a low of 7 and a high of 15. So every number has to be greater than, well, it has to be greater than or equal to 7 or less than or equal to 15. It has to be in that range. So you see here the 10 is between 7 and 15. The 7 is also, well, it's in the range because we include the low and the high, as well as the 15 is in the range because of the high is equal to 15. So we add those three numbers together, 7 plus 10 plus 15, we get 32. Example 2 here, the low is 6 and the high is 10. So the numbers that are acceptable are 10, 7, 6, and that's it. So 6, 7, 10. So they're just looking for the integer, which is the addition of all those numbers. All right. So how we're going to do this is we're going to use recursion, because you can't do a binary tree without using frickin' recursion. But one thing to note, in a binary tree, the root node will always be, as far as the left is concerned, the left tree, the root node will always be greater than any value in the left branch. So here, as you can see, all three of these numbers are less than 10. So when we traverse this, we get to 5, and we notice that 5 is outside the range of the low, which is 7. Therefore, anything to the left of 5 is going to be less than 5. So we can automatically exclude anything to the left. We still have to go to the right, but we can save some time by eliminating the left. The same can be said for the right branch. So anything to the right is going to be greater than the root. Now, as you can see here, we have 15, which is greater, and then 18. So the high is 15. So once we get to 15, we can basically exclude anything to the right because it's going to be greater than the previous node, which is 15. We still have to do the left, which in this case there is no left, but yeah, we can do a few shortcuts here. The same thing here, 10, 5. So the low is 6 and the high is 10. So 10, 5, this is already lower than 6. So we can exclude anything from the left branch here, and we just have to go through the right branch, and you can see the 7 and the 6 are actually valid. The same thing for the right here. You can see 15 is greater than the highest integer, so we can exclude everything here because it's automatically going to be higher than 15. So anyway, let's just start coding this and you'll kind of see what I'm talking about. All right. So the first thing we'll do here, because we're using recursion, we want to do this if root, whoops, put that in the parentheses, equals null. So this will, we're going to return 0, and this will break us out of the recursion. So we need to add all the numbers. So int sum equals, we'll initialize that to 0. All right. So now, if the root, which is the current node that we're looking at, if the root value is greater than or equal to the low, and let me go in here, and the root value is less than or equal to the high, so it's in between that range, then we're going to add this root val, the value of the root, to the sum. Alright, so where does the recursion come in? So we'll do this. If root val is greater than low. We only have to do this if the root value is greater than row. So greater than low. So sum equals, and now we're going to do the recursion here. Range sum BST, and we're going to increment the left value. And we're going to pass in the low and the high. So this, if root val is greater than low, so in other words, the low here is 6. So we get to 5 and we see that this value is not greater than low, so we'll just skip it. So that's why it skips everything on the left here. Now we need to take care of the right value. So if root val is less than high, then the sum plus equals range sum BST root. Now we're going to pass in the right. And again, the low and the high values. And then we'll just return the sum. And that is pretty much it. So let's debug this and see what we get. Okay, so I use the first example here, where the low is 7 and the high is 15. All right, so we're going to go through this. The root is not null. The sum is 0. So we're dealing with the value 10. So we're dealing with the root node here. So if root val is greater than or equal to low, which is true, and it's also less than or equal to high. So 10 is within the range. So if root value is greater than or equal to low, absolutely it is. So we're going to pass in the left, which will be the 5. So now if you look here, we're dealing with the 5. So that's not null, sum is 0. If root value is greater than low, it's not. Is it greater than the root value greater than low? Nope. But the root value is less than high. So now we need to take care, because we've eliminated the left here, we eliminated the 3, but now we need to take care of the right. So you look here, we're dealing with the 7. And it's not null. It is within the range, greater than equal to low, less than equal to high. Is not greater than or equal to the low, but it is less than or equal to the high. So we are dealing with, okay, so now the 7 doesn't have any child node, so it's just going to pass in null, which returns 0. Okay. So now we're still with the 7. We're going to return 7 because 7 doesn't have a right or a left node. So pass in 7. Now we're back to the 5. And the 5. Okay, yeah, now we're back. So we go back to the 10. So currently we have 7 and 10 using the recursion here. Okay, and now still in 10. Okay, now we're dealing with the right value. So we've got the 15. Sum's not 0. Both of these are true. It's greater than low, less than or equal to high, because it equals the high, actually. It's greater than low. So now we're dealing with the left side, which is null. And so now we're back to the 15, and we're going to do the right. And the right is 18, so it's not less than or equal to high, and so the sum is just the 15. And now we're back to the 10. And so we basically added 10 plus 15 plus 7, which gets the value 32, and that is our answer. All right, so let's run this and see what we get. It is accepted, and we'll submit it. Faster than 57%, and uses less memory than 89%. Okay, so the time complexity is O of n. We're just using recursion and looping through. And so as we increase the tree, we're going to increase the time it takes. And the same is true for the space complexity. As we increase the size of the tree, we increase the space needed to run the program. And that is it. So thanks again for watching. Let me know if you have questions, and we'll see you next time.